This question deals with vectors. So we have three position vectors OA, OB and OD. If we have a line, this point is A and this point is B, this is a line L that passes through the point A and B. So first of all we have to find the direction vector AB. So the direction vector AB is equals to the difference of the position vectors. So OB minus OA. OB minus OA. So if we subtract it, 5i minus 2i is 3i, plus 2i minus j is 3j, 10 minus 5, this is plus, 10 minus 5 is 5k. So we have the direction vector of AB. So the vector equation of a line is written as R, position vector of the first point through which it passes, which is OA. So this is going to be OA, plus lambda, direction vector of the 2 points, so AB, lambda AB. So this is going to be OA is going to be 2i minus j plus 5k plus lambda AB is going to be 3i plus 3j plus 5k. That's it. Question number C, we have to find the angle between the angle BAD, and we have to show that it is 109 degree. Now if you take a look at this, if this is B, this is A, then D is some other point outside. Suppose this is D, this point is D. So BAD is going to be this angle theta. Now this is AB and this is AD. The rule is, if you want to find the angle between two direction vectors, make sure they are coming outside from that point, meaning it has to be A to B arrow and A to D arrow. So let's write down the formula for angle. So cos theta equals to dot product of the direction vector, so AB and AD. So AB dot AD divided by modulus of the direction vector, so modulus of AB multiplied by modulus of AD. Now we already know the direction vector AB, we found it in the previous sum, but now we have to find the direction vector of AD before we can proceed. So AD equals to OD minus OA. So OD is minus I plus j plus 4k minus I plus j plus 4k minus OA is 2i minus j plus 5k, and this turns out to be minus I minus 2 is minus 3i, j minus j is plus 2j, and 4k minus 5 is minus k. So now we know AD, hence cos theta equals to AB dot AD is going to be, so AB is, we found it in the previous sum, 3i plus 3j plus 5k dot AD is minus 3i plus 2j minus k. Now we have to find the modulus of AB. So the modulus of AB is square root of coefficient of I squared plus coefficient of j squared plus coefficient of k squared. Square root of the modulus of AD is coefficient of I squared, which is minus 3 squared, coefficient of j squared is 2 squared, plus coefficient of k squared is minus 1 squared. So now we can do the dot product first. Now the idea of dot product is take the coefficient of I and multiply them. So 3 into minus 3 plus take the coefficient of j and multiply them. So that would be 3 into 2 plus take the coefficient of k and multiply them. That would be 5 into minus 1. So this is a dot product, also known as scalar product. It would have no ijk. So now this is square root of 3 square plus 3 square is 9 plus 9, 18. 18 plus 25 is 33. Sorry, it will be 43, not 33. Okay. Then square root of minus 3 square is 9. 9 plus 4 is 13. 13 plus 1 is 14. Square root of 14. So cos theta equals to, this is minus 9 plus 6, which is minus 3. Minus 3 minus 5 is minus 8, divided by square root of 43 times 14. Since you have different square root, you can just write one single square root, 43 into 14. So now we have to find theta. So therefore theta equals to cos inverse of minus 8 by square root of 43 times 14, and we have to use the calculator for that. So 109.03, so we were looking for 109 degree, and that's it, shown. Question number D says that we have to find C given that A, B, D and C make a parallelogram. So let's see what it can look like. So if you have a parallelogram like this, so the name of the parallelogram is ABCD. So if this is A, this is B, this is C, this is D. So we know the coordinates from the previous sum because the position vectors were given. Now we know that ABCD is a parallelogram. We have to find the coordinates of C. So this concept comes from the concept of O-level basic geometry, where we know that the midpoint of the parallelogram, the diagonals meet at the same time. So if you have this diagonal, if you find the midpoint of BD, then it would also be the midpoint of AC. So they will have the same midpoint. So X, Y, Z is the coordinate of C. So let's do this. So this is a rule we use from C1, how we find midpoint. So first of all, midpoint of BD equals to x1 plus x2 by 2. This is from C1 rule for midpoint. So x1 plus x2 by 2. Then y1 plus y2 by 2. And this is an additional one, z. z1 plus z2 by 2. This turns out to be 4 by 2 is 2. 3 by 2 is 3 by 2. And 14 by 2 is 7. So we found the midpoint of BD. Now we know that the midpoint of BD is the same as the midpoint of AC. That's the thing. The diagonals have the same midpoint. So now let me write midpoint of BD, AC. So midpoint of AC equals to, so now we have the midpoint of AC. Now we know, by since it's a parallelogram, that the midpoint of BD and the midpoint of AC are the same. So we can write the x coordinate of the midpoint of AC, 2 plus x by 2, is the same as the x coordinate of the midpoint of BD, which is 2. So we can write 2 plus x equals to 4. Therefore x equals to 2. We found the x coordinate of the midpoint. And the midpoint, the y coordinate of the midpoint of AC is also equal to the y coordinate of the midpoint of BD. If you cross multiply, minus 1 plus y equals to 3 by 2 into 2 is going to be 3. So y is going to be 4. And the z coordinate 5 plus z by 2 is equals to the z coordinate of BD. This is going to be 5 plus z equals to 14. Therefore z equals to 9. So it turns out the coordinates of C is going to be 2, the value of x is 2, the value of y is 4, and the value of z is 9. So we found the coordinate of C. But the question was, now you have to be very careful, which format do we have to write down the answer in? So we have to find the position vector of C. So the answer would be OC equals to 2i. Remember the conversion of Cartesian point to position vector. So 2i plus y coordinate will have a j plus 9k. That's OC. Now for the next question, question number E, this is also basic geometry. Find the area of the parallelogram. Now we know that the angle BAD, this particular angle, is 109 degree. We also know that AB has a modulus, and we already know that modulus, and AD also has a modulus means length. We found that in the previous sum. So yes, this is AB. So AB is square root of 43 and AD is square root of 14. So this is going to be square root of 43 square root of 14. Now let's find the area of triangle ABD. If we multiply by 2, we'll find the area of the entire parallelogram because it is made up of two equal triangles. So this is going to be question number E. So area equals to 2 into, since there are two triangles, half AB sine theta. So A is square root of 43, B is square root of 14. Remember the formula for area of a triangle. And this is sine 109 degree. So this is sine 109 degree. So this is the area of the triangle ABD, and if you multiply by 2, we'll find the area of the entire parallelogram. So let's calculate this. So this turns out to be 23.19. So that is 23.2. Question number F says the shortest distance from the point D to the line L. Now we know the line L passes through A and B. So basically the shortest distance from D to this line AB. So shortest distance means perpendicular distance, this distance. Let me draw this triangle over here. So if this is D and this is the shortest distance, so we can say if this is A, so this is 90 degrees, so this is the shortest distance H. And we know this angle is 109 degree, and we also know the length of AD is square root of 14. So this is question number F. So we have this right angle triangle where we have to find H. Now we can do this using some basic trigonometric ratio. We can write sine theta, meaning sine 109 degree, equals to opposite, which is H, divided by hypotenuse, because the angle is 90 degree and any side opposite 90 degree, the hypotenuse, so square root of 14. So that means H is going to be square root of 14 times sine 109 degree, and that turns out to be so 3.54 to 3 significant figure. So 3.54.